Alright, hello you crazy people out there, this is DragoniteSpam and welcome back to another one of these fancy game maker programming videos. So, once again, I have kind of been slacking on making these. Stuff happens. We'll try and be more consistent going forward. Anyway, if you couldn't tell by the title, this video is going to be about using two-dimensional primitives in Game Maker. And if you've never heard of them, that's fine. They've been around in this program for a few versions now, but they've never been really widely used. They aren't the most useful thing ever, but there are places where you could use them if you wanted to make things fairly simpler, make things look a little bit better than you could without them. Anyway, jumping into things, I'm going to make myself an object, and I'm going to call it shape, and I'm going to go and add something to the draw event. Now, GameMaker supplies a couple built-in types of shapes that you can draw, things like draw, triangle, things like this. And I think there's a couple more of them. These are just what I came up with off the top of my head in like 5 seconds. And I'm sure you all know how to use these already, but you could say for draw triangle something like x, y, x plus 64, something like that. You could say something like that. I'm going to go and add an instance of this to the room so that you can see what happens as if you already didn't, because I'm pretty sure everybody who would have clicked on this video knows what this does. It's going to draw something like this. You have yourself a little basic fancy triangle. But what if you wanted to draw something that wasn't covered by a triangle or a circle or a rectangle or whatever? What if you wanted, like, I don't know, an octagon or star-shaped thing or whatever this happens to be? Why would I ever want to draw that? I have no idea, but what if you wanted to do it anyway? What if you did want to draw one of these crazy things on the screen? There's a couple ways you could go about doing it. The first one would probably be the one that most people would do, and that is to create a sprite, and we're going to call this, like, SPR star or something like that, and it's going to be something ridiculous looking like that. I hope you like it. I spent all of 9 seconds of it. And that is certainly one valid solution. Another one that people might come up with is to use a bunch of the different basic shapes, say a bunch of different triangles, and chain them together and draw them all at the same time and align them so that they form a different shape. For example, you could draw 8 triangles configured in a certain way, like around a central point, and that would form an octagon. Or you could use the 2D primitives. So I suppose the best way to demonstrate this is I'm going to start things off with this little function call, and it's going to take an argument, and that would be the primitive type, constant for primitive type. And you have a couple options here. I'm going to go with triangle strip, no, triangle list. For now, I'll explain another 5 by the end of the video, don't worry. Next, I'm going to just end it off, so pretty much the same way if you'd ever make a block of curly braces to organize a set of code or something. Write your beginning and your end first, and then fill in everything in between. And now, I'm going to do 3 function calls fairly similar to each other. They're going to look like this. Okay, wonderful, and when I run the game, it is going to look exactly like the triangle that I drew with the 1 line of code a little while ago. Yes, you get to use 5 lines of code instead of 1 to do 1 specific action. It's wonderful, isn't it? Bear with me, there are places where this could come in useful. And like I said before, I will get to that by the end of the video. So, what this does is it takes these 3 points, and it fills them in. And the way it's going to do that is going to be defined by the different argument that you pass it here. You could say, instead of PR triangle list, you could say something like point list. And I'm going to do that real quick. And all this is going to do is draw the specific points on the screen. It's not going to fill them in at all. You can barely see them. I'll zoom in on the video a little bit so you can see them a little better. But right now they just look like specks of dust on the monitor. I don't really think that that is the most useful type of primitive to draw in the world. But that could just be me. Additionally, you also do have this little function here, draw a point, and that could do the exact same thing as this great big block will. I think there might be a slight advantage in terms of program speed, but I'm not quite sure about that. I'll look that up and put it in a little annotation while I'm editing this. Next, you have line list, and that's going to take the points and it's going to draw lines between them. And in this case, it's only drawing a line between one of them because it does require that you have these vertices in sets of 2. Something like that will make the second one show up, and it's going to draw a point between x plus 64 and y, and x plus 64 and y plus 64, if that has any meaning to you at all. And once again, you could do the exact same thing with just draw line using a couple of those functions. Next up, you have line strip. And this is where things start to get interesting. I am going to go and comment out that one for the time being. And what this is going to do, I'll explain it after you can see what it does on the screen. What this is going to do is it's going to take the endpoint of one line and use that as the starting point of the next line. So I'm going to just move this off so I can come back to it. First, what it's going to do is it's going to draw a line between these 2 points, and then it's going to draw a line between these 2 points, and then should there be however many more vertices on the list, it's going to keep doing that, grouping them like this until it gets to the end. So that could be somewhat useful if you want to make sure that you have a shape made of lines that doesn't ever have a break in it. If you want it to be like one continuous sort of boundary sort of thing. Next, triangle list. I already did talk about this, although I don't think I mentioned this, but it is worth noting that these vertices lists do have to be in sets of 3. You can have as many of them as you want within the code that's drawing the primitive, as with the lines, but they do have to be in sets of 3 because it's going to take each set and treat it as its own entity. And I'm going to just quickly move this over a little bit from the original one. By 100 pixels, I'm going to start the game. I'm going to close out of this window and start the game so you can see that it's going to draw 2 triangles. Just like that, translated 100 pixels down and to the right. And if I were to take one of these out, it wouldn't draw a line between the first 2, but it would not draw anything at all for the second triangle. As you can see, there's nothing here, not even a line. These have to be in sets of 3. Next, triangle strip. As the name might imply, this works very similarly to line list. If I were to run the game now, it would look exceedingly weird. I don't even know what that's supposed to be, like a weird broken boomerang or something. So I'm going to close out of that. What this does, similar to line strip, is it takes these 3, then it goes to the next one and it takes these 3, and then the next one these 3, and it keeps going that, and it keeps doing that until it gets to the end of the list. If you were to go and actually put some thought into the points that you're choosing for this, you might get something that looks like, let's say this, and that's going to kind of make a sort of a, not really a rectangle, like a trapezoid sort of thing. I don't remember what a regular quadrilateral is officially called. It wouldn't be a trapezoid because those have to have a right angle in it. Anyway, whatever the shape is called, it's going to do that. It's kind of hard to visualize exactly what's going on with its sets of 3 in the program because it fills it in. It doesn't just draw the outlines or anything. So while I'm editing, I will go right about now and draw another picture, scan it in, put it in the video so that hopefully you'll be able to see what it does a little bit clearer if you weren't quite sure. Lastly, this one's personally my favorite. It's kind of the hardest to get the hang of, but I definitely like it. Triangle fan. And what this does, I didn't want to do that, is it takes the first point, you give it as the center, and then it proceeds to draw a bunch of triangles around it. So if the other one was a little confusing to get the hang of, this is really weird. So I'm just going to go and give it, how about this point, the first 4 of the other shape that I was drawing. And it's going to do something, and it's going to look really bizarre like this. Once again, as with the last one, it would probably help if I drew a picture with like a pencil and paper and outlines instead of being completely filled in as to what's going on here. But it's taking this point here. I don't know if my screen capture is recording my mouse or not. Okay, good, it is recording my mouse. But it's going to take this point here, and then it's going to look at the next 2, and that's going to form a triangle out of them. So it's going to go here, here, and here. And then instead of, maybe I could explain it like this. Instead of being like triangle strip and taking these 3 points, it's going to take the first one and then these 2 points. So that would be the first one, the origin, this one, and this one. And that sounds really, really weird at first, but to explain it another way, I'm going to be using a circle. So I'm going to be saying that, and I'm going to be saying for, alright, so like this, I'm going to be setting up a simple for loop from 0 to 360, not inclusive, and it's going to be taking in an increment of 45. And I'm going to be saying draw vertex x plus, how about 80 times cosine of the radian equivalent of I, and y minus 80 times the sine of the radian equivalent of I, and I'm going to be drawing it, running the game, whatever, and I'm going to be running the game. So what this is going to do, I think this shows what's going on a lot better, is it's going to draw an octagon. So I mentioned octagons earlier, so to explain it a little bit better, what it's going to do is it's going to take the center point, the original point, that would be simply xy over there, and after that it's going to take the first 2 points that are drawn, which would be these 2, and it's going to make a triangle out of them, so it's going to go here, here, and here. And then it's going to take the last point that was drawn, the next point that was drawn, and the origin, and it's going to make another triangle out of them, and it's going to keep going until it hits the end, and that's going to form basically an octagon. If you want it to be filled in, if you want it to like not have that weird Pac-Man like break in the middle, you just say I is less than or equals to 360, and that last equals will close the circle, close the octagon rather, so it looks something like this, and that would be how you draw an octagon through code. If you wanted to give it more vertices, if you wanted to make it like a hexagon or a dodecagon or what's one with 20? Icosagon? I don't even know if that's actually what it's called, but you could change this value that I is incremented by. You could make it 60, and this will give you a hexagon like this. You could make it 30, and that'll give you a dodecagon. That would look something like this. You can go and count the points. You can go and count the vertices if you don't believe me. If you want to be able to draw a shape with any given number of vertices, say heptagon, which would be 7 vertices instead of 8 for an octagon, or like a nonagon, which would be 9, or whatever in the world you could possibly ever want to draw. You could make another variable, so I'm just going to call this points, and I'm going to say points equals 360 divided by whatever you want. So if you want a nonagon, which would be 9 vertices, I guess corners if you'd rather call them that, you could say point equals 360 divided by 9. And then instead of saying I plus equals 30 or whatever, you would say I plus equals point. And that'll evenly divide it up. You could see, let's count them 1, 2, 3, 4, 5, 6, 7, 8, 9. If you wanted, for whatever reason, to make it, I don't know, like 35 points, this is going to look really strange. You could say 360 divided by 35. And that's essentially come out to be a circle because they're so close together. I'm going to make that something small. Let's make that like 15. Should be easier to see. There I go, that's better. Yeah, 15 points here. You can count them if you want to. If you make it a decimal, say if you want to make it like 6.5 instead of 6, this will give you, it's going to give you something weird like this, where it has 7 points. Count them 1, 2, 3, 4, 5, 6, 7. Yeah, 7 points, but it doesn't close all the way. I'm not going to spend too much time on things like that. I'm just going to go back to make this 8, and that'll be an octagon. And I'm going to actually go and save this and not delete it when I do my next example. And I'm going to put this in a little script over here, and I'm going to call it like a, I don't know, draw octagon or something like that. I will have this file available for download in the description of this video like I usually do with these tutorial things, so if you want to go and mess around with it. Next, I'm going to go back and make it a little bit simpler. I'm going to go back to the basic triangle. So instead of triangle fin, it's going to be triangle list. I'm going to go back to drawing this once again. I think that's what it was originally, but either way, it doesn't really matter. The point is, I don't even know why I ran the game. It's a simple little triangle. Okay, so it's rotated a couple degrees. And I'm going to change this up slightly. So I'm going to say instead of draw vertex color. No. There we go, draw vertex color. And for whatever reason, I think because Yo-Yo Games, the company that makes Game Maker, is from some other country that doesn't use like American spelling. If you want the code help to show up at the bottom of the screen here, you need a U in the word color. It'll still work with the American spelling, but it just won't give you the code help. Nothing major, just worth pointing out. But after that, I don't know why it's not like highlighting the line where the error is happening on. Probably have something screwed up in the preferences over there. I'll deal with that off recording. But this is going to take a couple other arguments. The color, so I'm just going to say C red and alpha, which I'm going to make 1. And over here, I'm going to say C, how about green and 1, and blue for the last one. All right, so that is going to give us a triangle. If you couldn't already guess what's going on, it's going to take the triangle and it's going to color them like this. It's going to color all the different points. So red, green, and blue, and it's going to be sort of blended, interpolated between them. Actually, I'm going to make the triangle a little bit bigger. I'm going to make it a double size, so 128, and how about 64? Just so that it's a little easier to see. Let's see, is this going to be better? Okay, yeah, that's going to be a lot better. This is fairly straightforward. You're drawing a triangle, same as before, except the points are going to be specified colors. Once again, I think, yeah, okay, so over here you do have a function, draw triangle color, that'll let you essentially do the same thing as you would over here. You have your points, the X, Y points, and you also have the 3 colors that you would specify. So as with before, this isn't the most useful block of code ever, but there are a couple fairly more interesting things you can do here. I actually have some code written off recording that I'm just going to copy and paste and explain in a minute. And I'm going to go and run the game. And it's going to give you something fairly interesting. that looks like this, and it's a bar with a rainbow of colors in it. So I'm going to move this over to the other screen. This is just a triangle strip, so it's going to be drawing like consecutive sets of threes like this, as I explained a little while ago. And the first one it's going to do is going to be red, and then it's going to come over here and it's going to do orange, and then it's going to come over here and do yellow. And then it's going to do these three, which are going to be orange, yellow, and green, and then these three, which are going to be yellow, green, and I forget where I put the next point, but it's going to be blue. And it's going to have a nice little rainbow effect to it. I could definitely see situations where that sort of thing would be useful to have. If you wanted to have some fancy rainbow effects in like the background of your game or something. Or I don't know, maybe some mystical key item that does some fancy thing and it looks fancy and stuff like that. Another thing that I came up with when I was messing around earlier, I'm going to come back to the circle. This isn't terribly important, but I thought it was kind of interesting. So I'm just going to copy and paste it and explain it in a minute. If you do this, if you can read this, I'll explain it in a minute. You can draw through code a color wheel of sorts, or you have white in the middle, or if you wanted to, you could make it black or another color in the middle. And then you have red, and it rotates yellow, green, light blue, blue, magenta sort of, and then back to red. And this is essentially one of those octagon shapes with 120 corners, 120 vertices. And the code that makes the color like that would be here, where you, I guess you could say you loop through the hue from 0 to 255, and 0 would be red, and 255 would also be red, and somewhere in the middle would be like orange, yellow, green, that sort of thing. And you loop through that using the circle variable I. There are a bunch of interesting things you could do of that nature, but I don't want to spend too much time talking about that. Now that I think about it, I should probably, instead of putting up this project file in the video description, I should probably use the one I was messing around with last night, because it's a little bit better organized. Anyway, I said earlier that I'd talk about the advantages and disadvantages of using things like sprites versus the primitives. The main difference would be, if you're familiar with programs like Adobe Photoshop and Adobe Illustrator, sprites are raster images, meaning that if you open them up, I'm going to open this up, I'm going to zoom in really close on this, and you can see it's composed of a bunch of pixels, and each pixel is one very specific dot at a point on the image. And the advantage of using sprites, raster images, is that they're easy to manipulate. If you don't happen to like the color on one little tiny part, you can just go and like fill it in, do it whatever. That looks like it's diseased, so I'm not going to keep it. You could also store things like actual pictures, sprites like Super Mario or a Pokemon or whatever, or even like a photo or for a background or whatever if you really want to, because they do store each pixel individually. So all in all, sprites are good for things with a lot of detail and things that you want to be able to change easily, like your playable character. I'm going to get rid of these weird red dots because they're just driving me crazy. When you go in here and you draw shapes, on the other hand, these are defined by math. They're defined by numbers that you give it. They're defined by the mathematical operations that you give the primitive function to tell them how to connect them. They don't store information for each individual point on the picture. Well, they could if you wanted to define a point of a certain color for every single pixel in the image that you want to draw, but that would be hugely inefficient, so I'm not even going to talk about that. These are good if you want to have your basic shapes, or if you want to scale them, or if you want to be able to change things like how many vertices they have. I put this in a function which actually, I wasn't thinking about this 5 minutes ago, but it's not a bad idea to demonstrate the second point I wanted to make. But say you wanted to have one function that could draw any shape with any number of points, and it could also be of any size. However, because of this, because the information that it stores is just math, you could, if you wanted to, scale this any number of times that you want to. So I'm going to say 250, how about? This is going to be a circle of radius 250. And I don't want to run the game, I wanted to go and put it in here, draw Octagon. And I didn't want to do that either because I needed the parentheses. I'm just not exactly on the ball today, am I? Alright, now we're going to run the game. Alright, it's going to do this. You have your octagon, and while if you had a sprite that had a picture of an octagon in it, and you wanted to scale it up like this, you would find the edges getting all pixelated because the sprite would have a certain specific finite number of pixels in it. And when it scales them, it would just draw them bigger than they already are, or it would draw them smaller than they already are, and when they get really big or really small, they just start to look really funny. The Octagon doesn't have that. As you can see, right now it looks just as smooth as it did when it was smaller. Now the last thing here, the last benefit of using primitives to draw weird shapes instead of sprites, is that while you can't manipulate every single specific pixel on the picture, like changing the color of somebody's nose in a photograph or something like that. You can change it in certain ways, like I'm going to go and write myself a method signature. I'm also going to rename this to draw shape. That may give you an idea of where I'm going with this, but draw shape. And I'm going to give it 2 arguments for size and corners. Alright, just like that. And instead of saying point equals 360 over 8, it's going to be 360 over corners. And instead of the 250 being there, 250 times cosine, 250 times sine, it's going to be size. And it's going to look something like that. And we're going to go back to shape, and we're going to go and pass the arguments. How about 120 and 10? And we're going to also want to rename this so that the game actually knows what it is, but it's going to have a radius of 120 pixels, and it's going to have 10 corners, 10 vertices, whatever you want to call it. And it's going to do just exactly that. And in this case, I'm sure you could already see this now that I finished with it, but you can change things like the size or the number of corners it has very easily just through code, instead of having, if you were to use a sprite for that, instead of having to go into the picture and go to all the effort of changing the actual picture. So there you have it. If you really, really wanted to go all the way, you could actually do animation with the primitives fairly easily, but that is, if anything, a subject for its own video, and I'm not going to go there today. So, that's primitives. Like I said at the beginning, they're not the most useful thing in the world, but you can do a number of cool things with them. If you want to have a copy of this project file that I'm working over on at the side here, that I was working on last night with a couple other examples like this, little star, a little rainbow strip, a little color wheel, a little seashell shaped thing, I will be putting this file up for download in the description of this video. But for now, I hope you all enjoyed that. Rate, comment, and subscribe. Watch some other stuff I've uploaded, and I will see you all later.